I have been asked to talk about the North Atlantic and global climate change. I think everybody here knows that the climate is changing. It is changing because we humans put a lot of carbon dioxide and other so-called greenhouse gases into the atmosphere. It will continue to change. It will get worse if our politicians around the world manage to curb the emissions, then perhaps not to catastrophic levels, but it will get worse. It will affect nature. It will affect human societies. That is, today, there is no doubt about that. But it's not really my task to talk about all these overarching questions. I believe Al Gore will do that, and he's certainly well suited for that. He's done a tremendous job in communicating the dangers of global climate change to the world public, to the world's politicians. We might perhaps hope that his visit here could help our politicians to behave more responsibly in the future in this regard than they have done in the past. My task is more restricted. I'm to talk about the North Atlantic, so just one part of the climate system. And you might perhaps wonder, why talk about the North Atlantic at all? What has that got to do with climate, or even what has the ocean got to do with climate? So I'd like to start by convincing you that the ocean, and perhaps especially this part of the ocean close to us, those of you who might wonder, this is where we are in the yellow circle, that this ocean is fairly important to climate. And let me start by carbon dioxide, or carbon, anthropogenic carbon. That means carbon produced, emitted by mankind. It's been estimated that during the last 250 years or so, we have emitted something like 400 gigatons of carbon. It's about 400 billion tons, 400 miljarder in Faroese. But if you look at where that carbon has gone, only a part of it remains in the atmosphere, fortunately. Some of it has gone into vegetation and soil on land, and some of it has gone into the ocean. So only 45% remain in the atmosphere, with 25% on land and 30% in the ocean, approximately. And you might imagine if the ocean had not helped the atmosphere in this way, climate change would be worse today than it is. And if you look at now, where in the ocean has this anthropogenic carbon gone? It's shown with the figures in this map. The blue and violet areas have very small values. The red and brown areas have much larger values of the amount of carbon beneath each square meter of sea surface. So you see quite clearly the North Atlantic has done a very good job in removing carbon dioxide from the atmosphere, helping the atmosphere not heat too much. And if we look at the energy, as a consequence of the greenhouse gases, the Earth has absorbed more heat than it would otherwise have done. And if we look at where that heat has gone, that the Earth has absorbed from 55 to 1998, this excess heat, only a very small part remains in the atmosphere. Somewhat more has gone into land, into melting glaciers and things like that, but by far the largest amount has gone into the ocean. Imagine how the climate would be today if the ocean had not taken all this heat, if it had to remain a large part of it in the atmosphere. It would be terrible. And there's a further aspect of this. The ocean it's the surface of the ocean that absorbs the heat. But then the heat is distributed further down into the depths of the ocean. But that's a process that takes time. We say that the ocean has thermal inertia. And what the consequence of that is that even if all the politicians in the world today said, now we have to stop this madness, so we curb the emissions, they will remain at a constant level, the climate would still become worse for some decades. The Earth would still warm maybe about 0.5 degrees. It's like driving along in a car with high speeds and you see something in front of you and you want to stop. But from the moment you push the brake, the car continues for quite a while. And the ocean has this effect upon global climate. So, again, if you ask what parts of the ocean, this figure shows an estimate of the excess heat due to carbon dioxide emissions, due to greenhouse gas emissions. Where will that heat go in the ocean? And again, the yellow values here, they are very small, while the red and brown values, those are very high amounts of heat stored beneath each square meter of sea surface. Again, you see, it is the Atlantic, especially the North Atlantic. So I think you will have to agree that the North Atlantic is a very important part of the climate system. And you might ask, why? What is so special about this region? The answer to that is something which actually also is very important to us who live here. And I try to illustrate that with this figure. It shows the temperature in the sea surface during the last half year. From November 2007 up until a few weeks ago, one picture each week, which it then cycles through. It's very nice. You see, the equatorial regions are, of course, much warmer than most other areas. They are red, whereas the regions close to the poles are blue and cold. But what is quite special is that you see this region here, where warm water extends northwards. There is no other area in the world where you find as warm water as far away from the equator, which is very nice for us. And if you ask, why is this? Well, there is never just one answer to any question like this, but a very large part of that answer lies in the flow, the currents that bring these warm waters towards us and past us, what we here usually call the Gulf Stream. But then, of course, you have to ask, well, if this is so exceptional, then why do we have this? Why are we exceptional? To understand that, you need to look at the bottom topography, which I've tried to illustrate here. The fact is that the Faroes, technology goes too fast. The Faroes are located on a submarine ridge going from Greenland over Iceland and Faroes to Scotland. This ridge separates the ocean areas north of the Nordic Seas and the Arctic Ocean from the rest of the world ocean. And it's like a giant bathtub, these regions north of us, and we are on the rim of that bathtub. And then we have this flow of warm water going past us, which keeps our climate so mild, but it continues northwards, sends a branch into the Barents Sea, another branch into the Arctic Ocean.